Hello everybody, this is Mr. McNair, and these are the 2009 questions from the OGT that have to deal with geometry and spatial sense. Go ahead and take a moment, pause the video, and read through these tips. Alright, before we get into the questions for this section, I want to go over a couple of facts about angles and lines. Every line is made up of 180 degrees. If you measure a line from one point on the line to the next, that's a total of 180 degrees. So, knowing that fact, we could actually add up, in this problem, we can add up our angles that we know. 60 plus 90 is 150. So we have 150 degrees so far. And because we know that it has to add up to 180, we know that x has to be what? X would have to be 30. Okay, and if you didn't know that, you could actually just write it in an equation form: 150 degrees plus x equals 180, and then subtract 150 from both sides, and you would get that x equals 30. Okay, some other facts you should know. Vertical angles are always going to be equal to each other. Vertical angles are like these. This angle and this angle are vertical angles. Vertical angles make like two V's. Okay? They're right across from each other. So once again, this angle and this angle are vertical angles, so those measures would be equal. This angle here and this angle here would be vertical angles, so those measures would be equal. This angle up here, this angle up here, those are vertical angles, so those measures would also be equal. All right, corresponding angles are equal. Now, corresponding angles are equal specifically when you have a transversal. This is called a transversal. It's a line that cuts between two lines. And when you have a transversal that cuts between two parallel lines, corresponding angles are going to be equal to each other. Corresponding means that they are located in the same position. Like, for example, this angle is corresponding with this angle, because those are located in the same position in their region. Like, by region, I mean in this set of angles and this set of angles. Notice that our corresponding angles, this one here and here, they're both located in the lower right. So those are in the same position, so those would be equal measure. Okay? What other angles will be corresponding? How about this angle here and this angle here? Those would be corresponding, because those are both in the upper left. What about this angle and this angle? Those are both in the lower left of their regions. Okay, so those are corresponding angles. Also, alternate interior angles are equal. Once again, alternate interior angles, you would know something is alternate interior if they're on opposite sides of the transversal. So one's on the left of it, and the other one's on the right of it. And it's on the interior of your two parallel lines. Okay, the interior of the two parallel lines would be in this region here. This is the interior. So they have to be on the opposite sides of the transversal and on the interior. So for example, alternate interior would be like this angle and this angle. Those measures would be equal. Or even this angle here and this angle here. Those measures would be equal. All right. Also, alternate exterior angles have equal measure. Once again, they're going to be on opposite, alternate meaning opposite sides of the transversal, and that's our transversal. And they're going to be on the exterior of your two parallel lines. So the exterior of the two parallel lines, again, would be like up here. This would be the exterior, and this would be the exterior also. Okay? So those will be the exterior of those two lines. They'll be opposite sides of the transversal and on the exterior. So examples of alternate exterior angles would be like here and here. Okay, or even here and here. Those would be alternate exterior, and those measures would be equal. All right, all that being said, let's go to problem number 3. In which figure is the measure of angle 1 equal to 45 degrees? Now, if we look at choice A, we should remember that every line has a total of how many degrees? 180. So that means that when I add up the 45, and whatever angle 1 is, we don't know what it is. Whatever it is, all of those three should add up to 180 degrees. So 45 plus 45 plus whatever the measure of angle 1 is has to equal 180. Well, we know that 45 plus 45 is 90. And most of you probably could guess that measure of angle 1 in this case would have to be 90 degrees, because 90 plus 90 would give you 180. All right, but just in case you didn't know that, you can subtract 90 from both sides and say, okay, the measure of angle 1 equals 90 degrees. So this is 90. Well, the problem wants us to have 45, so it's not going to be that answer. So A is not it. Okay? Let's look at B. B, we have that this angle measure is 145 degrees, and we don't know what that is yet. So what you could use is the fact that you know that corresponding angles are equal. This is 145 degrees, so that means that this angle here has to be 145 degrees. This angle right here, that's 145. And since this angle plus this angle make a full line, you know that 145 plus the measure of angle 1 has to equal 180 degrees. Alright, so if you subtracted 145 from both sides, you would find that the measure of angle 1 would equal 35 degrees. So this is 35, but once again, we don't want 35, we want 45. So that's not going to be the answer either. So we can cancel that one out. All right, let's look at C. C is actually similar to B. Here, again, we should notice that this makes a full line. So that's going to be how many degrees? 180. Okay, so just like in the last problem, we know that this would have to be 35 degrees because 145 plus 35 is 180. So it can't be that. So by process of elimination, we know the answer is D, but let's just check. So in D, we see that this angle is a right angle because of that little box there. And we know every right angle is how many degrees? 90. So we know that the whole thing is 90 degrees. So 45 degrees plus the measure of angle 1 equals 90 degrees. Now, most of you should know that 45 plus 45 equals 90, but just in case you didn't, you can subtract 45 from both sides and find that the measure of angle 1 equals 45 degrees. And that's what we want. So the answer here is D. Okay, let's go on to the next problem. Number 7. This net is folded to produce a three-dimensional figure. Which object will this net produce? Now, just to review, a net is a two-dimensional figure that when you fold it makes a three-dimensional figure, right? So here, if we were to fold this along the lines, okay, these ends would come in. All right. Now, a couple things that you should notice when you fold that is that the circles are on opposite sides of each other, and the squares or the rectangles, whichever those are on opposite sides of each other. So you could kind of eliminate some choices here, because in B, for example, you have circles that are adjacent to each other, meaning they're right next to each other, they're touching, and that's not what our net looks like. Same thing with D. In C and A, here you can kind of look at a couple different things. Number one, the figure in our net, it has a rectangle or a square on the bottom. This would, when you fold it in, you're going to have a square on the bottom, making a rectangular pyramid. Okay, so a rectangular pyramid looks like they did in A and B. So C is not even a rectangular pyramid, so we can cancel that one out. So the answer by a process of elimination, again, is A. All right, next. Number 18, trapezoid RSTU is shown on the grid. Which graph shows the image of trapezoid RSTU after it is translated 5 units up and 3 units to the left? Easiest way to do this problem is take each of the points, each of the vertices, R, S, T, and U, and move each of those 5 units up and 3 units to the left. Okay, so let's go ahead and start that. Let's start with S. Okay, if we took S and moved it 5 up, 1, 2, 3, 4, 5, and 3 to the left, 1, 2, 3, it'd be here. So our new S would be there. We'll call that S prime. Okay, same thing with T. If we started with T and then we moved it 5 up, 1, 2, 3, 4, 5, 3 to the left, 1, 2, 3, our new T would be there. That's called T prime. Let's do the same thing with U. U, we're going to move it 5 up, 1, 2, 3, 4, 5, 3 to the left, 1, 2, 3. So there's our new U, U prime. And again with R. Once again, we'll go 5 up, 1, 2, 3, 4, 5, and 3 to the left, 1, 2, 3. So there's our new R, R prime. I'm going to go ahead and connect these with lines so that our figure looks just like our original image, our pre-image. All right. So from here, you have your new figure. It's 5 units up and 3 units to the left. And now you're just going to compare all of the points, all of your vertices, and cancel out the ones that don't match up. Find the one that does. And the one that does match up is A. Whoops. A. There you go. All right. So A is our new image. All right, let's go to the next problem. Number 23, Q, R, and W are plotted on the coordinate grid. Where should point Z be plotted so that parallelogram QRWZ is formed? Now, first thing that you should realize about this one is you should realize, or you should know, what a parallelogram is. Okay? A parallelogram is kind of like it sounds. A parallelogram has opposite sides parallel. Keyword is parallel. Okay? So, we want to plot all of these points and find out which of those make opposite sides to be parallel. Now, a couple things you should know, well, one thing you should know really, is that every ordered pair is an X first and a Y second. So you're going to plot along your X-axis. This is your X-axis here. Okay, so we'll just label that X-axis, and this is our Y-axis here. Okay, so we'll label that the Y-axis, and then we'll go ahead and plot our points. Let's start with A. Once again, this is your X, and this is your Y. So A, we're going to start at -2, -6 for the Y. So that's the point there. Now, let's look and see if that makes a parallelogram. Here will be one line, here will be one line. Automatically, when we make those two lines, we see that these red lines aren't going to be parallel. Remember, parallel lines go in, they never touch. They're in the same direction, and they'll never intersect. Those are parallel lines. Those are parallel lines. You know, these are parallel lines. They never touch. RW and QZ, there, they wouldn't be parallel. So that's not going to work. Okay? So we'll cancel A. Let's try B. B, -1, -3. Here's -1 on the X, -3 on the Y, so that's the point there. Let's go ahead and connect the dots. Those look parallel. These look parallel too. That looks like it works. So B looks like it'll be our answer. But just to make sure, I would go through and check. Okay? So let's go ahead and check through this, just to make sure that we're right. All right. Let's try C. All right. C, we're at the point 3 for the X and -2 for the Y, so that would be the point there. If we connected the dots, we see right here automatically that those two lines wouldn't be parallel. So that's not going to be it. So we'll cancel out that one. And let's try 2, -1. 2 for the X, -1 for the Y. So that would be the point there. If I connect those lines again, those opposite sides are not parallel. So we can cancel out that one as well. So B truly was our answer. All right, number 29. Similar trapezoids are shown. What is the value of N? Now, similar, the word similar means that they are same shape but different sizes. Something that you should know about similar figures is that corresponding sides are proportionate. Meaning, corresponding meaning, once again, in the same position. Like this side corresponds with this side here. And this side here on the bottom corresponds with this side here. Okay? All right. So from there, we can go ahead and we can actually start figuring out how we can figure out what n is. Now, a couple things that you could do. I would look at this problem, and the first thing I would notice is that there's certain values in the choices that you can kind of eliminate. All right, we're trying to find n. Now, from these choices here, which one do you think you can eliminate? I automatically would eliminate D and A. D is too big, A is too small. All right, from there though, you could actually keep going and try to figure out other ways to find out what n is. So I would look at this problem and say, okay, well, if I drew a line here, this would make a right triangle. Okay, now that I have that right triangle there, I know that this right triangle, the 4, this side here, is the hypotenuse. It's the longest side. So since 4 is the longest side, this portion right here has to be smaller than that. So it has to be something like 2 or 3. This portion down here, the rest of that blue, the rest of this is already 6. So I know that this total side is about 8. Okay? Now, some people might say, well, you said you knew it's about 2. Well, actually, I knew it's exactly 2, simply because if you know some properties of 30, 60, 90 triangles, because this side right here is 60, excuse me, this angle is 60, this angle in here has to be 30. When you have a 30, 60, 90 triangle, meaning the angles are 30, 60, and 90, the side that is across from the 30 degrees is always going to be half the hypotenuse. Always. This is 4, so this is 2. If this was something like 20, that would have had to been 10. It's always going to be half the hypotenuse, the side across from the 30. Okay? Now that I know that this whole side is 8, I can use my proportions to solve for n. So 6 is to 8 as 9 is to n. Okay? From there, you can cross multiply. So what's 6 times n? Well, that's 6n. And what's 8 times 9? Well, that is 72. Divide by 6 on both sides, you get n equals 12. All right? So there's our answer. All right, and that's what we call cross multiplying. Most of you probably know about that. If you don't know about that, you might want to come in, get a little bit of extra help on that. Okay? All right, before we go into the next problem, let's talk about some of the properties of right triangles. In the properties of right triangles, there is a phrase, SOHCAHTOA. SOHCAHTOA. And SOHCAHTOA helps us to memorize the trigonometric functions that go along with the sides of a right triangle. Here, the trig function is sine. Sine is opposite divided by hypotenuse. Here, cosine. Cosine is adjacent divided by hypotenuse, or adjacent over hypotenuse. And then the last one, tangent. Tangent is opposite over adjacent. Okay? SOHCAHTOA. Go ahead and please know that phrase. All right, so write a trigonometric relationship that can be used to find x. This is a problem that I just kind of threw in to practice SOHCAHTOA. So a trigonometric relationship. Here, from this 35, we know, or the figure gives us this side. Now, this side, in relation to 35, this side is opposite of the 35. So they give us an opposite. And this side right here, the 15, is what in that right triangle? It's the longest side. It's the hypotenuse. And remember, the hypotenuse is always across from the right angle. Okay? So they give us opposite and hypotenuse. Okay. Now, which trigonometric function uses opposite and hypotenuse? Well, let's go back to SOHCAHTOA. SOHCAHTOA, which one of those gives us opposite and hypotenuse? Well, the sine does. So what we can say is that the sine, now we abbreviate sine as just sin. Okay, so the sine of 35 degrees is going to be the opposite. And what is the opposite? That's x over the hypotenuse, and that's 15. So that would be the trigonometric relationship that you can use to find x. All right, let's go to the problem. Number 36, a ramp is being built next to a 4-inch high sidewalk as shown in the diagram below. Which trigonometric relationship could be used to find the value of x? So let's look at our angle. These are always going to be taken from an angle. And just so that you know also, these are always using right triangles. But anyway, our main angle is 10. We're never going to use the 90 degrees. We're always going to be using the other angle given. So our main angle is 10. From that 10, we are given this side right here, which is what? The opposite. So we're given the opposite, and we are also given this side right here, which is the adjacent. Adjacent simply means that it's the side that is touching the given angle. The side that's touching the given angle. Now, you might say, well, this side right here is touching the given angle too. And you're right, but that one's already labeled the hypotenuse because it's across from the right angle. So it couldn't be that one. The adjacent is the one that's touching the angle, but is not the hypotenuse. Okay? So, which of our trigonometric functions uses opposite over adjacent? Well, let's see. SOHCAHTOA. Which one uses opposite over adjacent? Well, that would be the tangent. Okay? Tangent is opposite over adjacent. O stands for opposite, A stands for adjacent. So, that means that the tangent of 10 degrees, and let me clear this out a little bit so I have some more room. In fact, let's rewrite that. The tangent of 10 degrees is going to be opposite again, and the opposite from 10 was 4, over the adjacent, which is x. So that would be C. Tangent of 10 degrees is 4 over x. Let's try one more just to be safe. All right, write a trigonometric relationship that can be used to find x. So again, they give us this angle down here. And from that angle, they give us this side. What side is that? That's the adjacent. What other side do they give us? They give us this right here. What is that? That's the hypotenuse. That's the longest side. It's the longest side, and it's across from the right angle. So, which trigonometric function uses adjacent and hypotenuse? Well, that would be the cosine. Cosine is adjacent over hypotenuse. So the cosine here, we can say the cosine of 50 degrees equals adjacent. Which side was the adjacent? The y. Over the hypotenuse, which was 7. So that would be your trigonometric relationship. Great. All right. Let's go to the next problem. Number 40. The vertices of a kite are located at the points P, -2, -1, Q, -1, -2, R, -2, -5, and S, -3, -2. The image of the kite is reflected over the x-axis. Then the reflected image is translated 3 units to the right and 2 units up. In your answer document, provide the coordinates for the vertices of the final image of the kite. Provide a graph, calculations, or reasoning to explain how you determine the coordinates. Well, let's go ahead and go through this problem one sentence and one step at a time. So the first sentence, the vertices of a kite are located at the points -2, -1, -1, -2, -2, -5, and -3, -2. So we want to take that and reflect it over the x-axis. Well, before we can reflect it, we actually do have to draw it. So let's plot these vertices, our points. So let's start off with P, -2, -1, -2, -1. So here's P. And then Q, -1, -2, -1, -2. That'd be Q here. Q. And then R is -2, -5, so that'd be here. And S, -3, -2, that'd be here. So there's S. I'm going to go ahead and connect these with lines. So here's our PQ, here's QR, here's RS, and here's PS. Okay, so that's our original image, our pre-image. The image of the kite is reflected over the x-axis. So once again, let's locate the x-axis. X-axis is here. Okay, this is our x-axis. Okay, I'm going to go ahead and label the x-axis. Now, when we reflect something over the x-axis, remember, it becomes like a mirror image. Okay, so the distance from the original point to the new point has to be the same. All right, so for example, P. If we notice, P is 1 away from the x-axis. So the new point has to be 1 away from the x-axis. So the new P, we'll call it P prime, is here. Same thing with Q. Q is 1, 2, 2 away from the x-axis. So the new Q, Q prime, would be 2 away from the x-axis. There that is. Let's do R. R is 1, 2, 3, 4, 5 away from the x-axis. So the new R, 1, 2, 3, 4, 5 away from the x-axis. So that'll be R prime. Same thing with S. 1, 2 away from the x-axis. 1, 2 is the new S away from the x-axis. S prime. All right, let's go ahead and connect those with lines. So here's R prime, S prime, S prime, P prime, P prime, Q prime, Q prime, R prime. Okay? So there's our reflected image. So we did that part. It says next, then the reflected image is translated 3 units to the right and 2 units up. 3 units to the right and 2 units up. So let's see, 3 units to the right. Let's go ahead and do that. So let's start with P prime. 3 to the right. 1, 2, 3, and 2 units up. 1, 2. So there's P double prime, we'll call it. All right, let's do the same thing with Q. Q prime. 1, 2, 3 to the right. 1, 2 up. So there's Q double prime. Let's do R. 3 to the right. 1, 2, 3. 2 up. 1, 2. So there's R double prime. And S. 3 to the right. 1, 2, 3. There's 1, 2, 3. And then 2 up. 1, 2. So there's S double prime. Again, we're going to go ahead and connect those with lines. So here's our final image. Okay, so there we go. We went 3 units to the right and 2 units up. So in your answer document, provide the coordinates for the vertices of the final image. So our final image, we had P double prime was at 1 for the X. Remember, always X first, Y next. So 1 for the X and 1, 2, 3 for the Y. Q double prime. Let's look and see. We're at 1, 2 for the X. And 1, 2, 3, 4 for the Y. R double prime. We're at 1 for the X. And 1, 2, 3, 4, 5, 6, 7 for the Y. So 1 for the X and 7 for the Y. And S double prime. We're at 0 for the X. And 1, 2, 3, 4 for the Y. And there you go. So we have provided a graph, and we have given all of the coordinates of the final image vertices. All right. And that's it for that slide, or for this section. Hopefully this has been helpful to you. Good luck with your studying.